Good afternoon, and welcome to our webinar today. My name is Darin GoEngineer, and I have been in the SolidWorks reseller community for my entire career since late 1990s area, 1997, and I've had the privilege of growing up with these products and watching the new things that the company delivers to us year over year. And every year is exciting, which is why this has been such a fun ride. Today, I get the privilege of delivering to you some of the new developments with our cloud applications. And one in development here that's a neat addition to a mechanical designer like me is our Subdivision modeling and our Sculptor application. So that's where we're going to be going with this today. So really quickly again, I've been around for a while, and again, I love these tools. They are part of me, and I've used them for a lot of things over the years. And if you get anything off of this slide right here, try and link up with us when it comes to social media, because that's where we're delivering a lot of this information, both in live webinars like we do here, as well as recorded content that we place up on our YouTube channel. We just reached over 110,000 subscribers there, so our content is coming out of all of our application engineers on a constant basis, and it's very valuable just based on the amount of people who are coming back for more. So we're really proud of that. But that's where this is going to land. So if you have any colleagues that were unable to visit us today, we're going to record this and get this up on our YouTube channel shortly. Once again, we are here to cover applications that are going to help our lives improve. And for me, I've been using these tools for my own personal benefit for a long time. And it's another method of learning because you use them towards projects that you're familiar with and passionate about. And in purpose, here for this, SolidWorks has always served me well when it comes to mechanical design, using things like weldments to design tree houses or decks or other things like that. But I have a particular love for 3D printing as well. So a lot of times I'm trying to build something that doesn't exist, creating something that bridges existing products like we have here that was part of another creation I'd made, or retooling or purposing something like this trolling motor. Now, when I created these types of bodies, I was using typical SolidWorks functionality for that. And it really goes along with the theme of what I want to show everybody here today. Now, the application I used was creating an organic shape that you see here on my boat and putting a mechanical component inside there, making it look like it was meant to be. But again, being more of a consumer facing good, feeling like an organic shape was really more appropriate. Now, I did that again with the tools that I had available to me at the time, which was not a tool like xShape and our 3D Sculptor roll. So doing what we're going to do today is really going to be more of a pulling back the curtains and demystifying some of the things that really opened my eyes up to what the capabilities were. So we're going to begin with a little bit of what is Subdivision modeling and kind of what is the big deal, but why will we use it? I have SolidWorks and many people out there do. And that's one way that you can, again, get things done. But when you have a purpose-built app, it's a different experience. And then we'll go into live demonstration. I promise you this will not be death by PowerPoint. I'm very much against that. I just want to kind of set things up, and we will get right to the live demonstration. So let's kind of further that on. So what is subdivision modeling? Well, very simply, the term that we would use very often would be free form. Now, free form is kind of an all-encompassing thing. What I feel or think about when I feel free form is pushing and pulling like I would on clay, organic surfaces. And that pretty much is what we're talking about. When you want to put a definition under it, complex, highly stylized, organic. Organic's a very good term. I use that quite often as well. But then, we're talking about aesthetically pleasing, ergonomically sound. The mouse that is in my hand right here most definitely has, these types of surfaces built into it. But was that built with a mechanical tool, or was that built with a sub-D type of a tool? Well, that's yet to be seen. Now, we've been showing, and I have somewhat air quotes going on here, some freeform shapes for years with SolidWorks. But I don't know that any one of the ones that we have here were actually created using a freeform function like a sub-D model. I know for certain that our C-scooter down here was not. That's created using more traditional functionality, sketches and lofts with guide curves. Same type of thing here with the Mako in many cases, because this, in many pieces, was a little bit pre-platform. But when it comes down to it, basically what we're talking about is creating these organic shapes. Now, this is a model that some of you may have been familiar with. In fact, this is a model that is really kind of the essence of what sub-D is, with these organic and very, very swoopy shapes, to use another technical term. But make no mistake, this is a SolidWorks model. And again, it's using those traditional functionalities. In fact, this model here, I pulled it up out of my archives. The last time I had saved it was actually in SolidWorks 2004. So to tell you how old this literal file is, it may have been even a little bit older than that. I'll credit Mark Biasotti, who was at SolidWorks at the time, for creating this. But it's done using traditional functionality. Once again, the ability to do it in SolidWorks, but not necessarily purpose-built. Now, recently, I've created this model, and we've got a little video series out there on our YouTube channel that I'll refer to a little bit later. And this is one of my childhood favorites. In fact, I have the clay model that I created when I was in high school. So we're talking 30 plus years on what I'm holding in my hand, and a few of these bits have broken off since then, but you know, Gorilla Glue is a wonderful thing. The point is creating these odd organic shapes is something that's necessary these days, whether it's for a figurine like you're seeing here, or whether it's for something that is a consumer good, the housing around some sort of electronic, earbuds. Everything has some sort of swoopy organic shape to it these days, and it has to. So we want to be able to do that, again, with a tool that's meant for the task. And this one was done using xShape, which is the Sculptor role on the 3DEXPERIENCE platform. We're going to get into that kind of stuff. Now, I want to get into demonstration one here. Like I said, I want to do this live. And I'm not going to go into the full-fledged demonstration of the Odie character there. I actually have the 3 videos on the YouTube channel I'll let you look to later. But what I want to do is I want to lay the foundation for what made that possible. Because the reality is when we're talking about sub-D modeling, we're not talking about a lot of things to know. We're just talking about a lot of repetition on the things you do know. And that really, to me, is the liberating part of this. Because it's less like mechanical design where you have an order of operations leading to a final result. Really, it's kind of a non-sequential way that we approach things. So I want to talk about these tools here, which are the key to the city, absolutely, with something like this. So what is a subdivisional body? Okay, that'll be simple. The robot, which is the push and pull mechanism used for absolutely everything selected on the screen. If you know this, you know how to do everything, really. Creases. Creases are really fantastic because they give you an essence of control over the body that you might not have known that you had. Dealing with the fact that a sub-D body, by definition, is Class A, or curvature continuous surfaces. Now, how to do loops and subdivides. That's where we add further and further detail as we go, and we start off with a less is more, and I'll get to that in just a moment. Now, the model that I want to use for this example, again, is not something I would necessarily call an exotic model, but it's going to show what I need to show and really, you know, kind of emphasize the points that we're talking about. And it's this model right here that I have in my hand, once again up on the camera here, and I'll bring it up on the screen. It's this model that I have of a glass massage. This is for rubbing a back, and basically it's got these nubs and these very soft points. And there's nothing really sharp about any of this. It works very, very well, and it's a shape, well, it's a shape that I really don't know how I would create in SolidWorks. I have to be honest with you. I think about lofting and sweeping instantly, but with the rounds that we have on the ends of these, I'm not lofting to a point. Nothing really kind of subscribes to those functions. So now we have to think boundary surfaces, fill surfaces with tangencies, and all kinds of other exotic surface functionality. Again, I can get this done, but when I look at it, how would I actually approach this in SolidWorks? Now, for this purpose, if I'm looking at it more of a mechanical drawing, I've got 3 views, and I might use those to match things up with shapes. You know, but for what we're going to do right now, I really don't think that's the best approach, and it's exactly why I wanted to bring up you know, xShape and how our Sculptor role is really kind of transforming my approach to things by giving me a tool that I really have never had access to before. So we would have to use absolutely all of these functions, if not more, to go ahead and create this in a mechanical design tool. Now, what about solids or surfaces? A completely additional consideration. All right, well, let's get into this right now and just show you exactly how something like this is going to be built, and it's going to be built 100% on the cloud. So here we go. First thing we're going to do is log into the platform. So let me just toggle over and actually get into my web interface. Now, I'm physically sitting on the platform right now. But one thing I ran into that was kind of interesting, and this was really, you know, one of those benefits that you get by just mingling with people at 3DEXPERIENCE World, which we just returned from. I needed to log into my platform while I was in Nashville, and I didn't have my laptop with me. And I don't know about you guys, but those of you who are current platform customers, you might think that you have to know your platform ID, which on my screen here, I'm not hiding. It's my R number, but I don't know that number. and I thought I was going to have to get to my computer or somehow figure that out. Well, somebody within earshot heard me say that, and they said, nope, just go to www.solidworks.com/xdesign. Guess what that does for you? I'm going to show you. Well, here if I open up another tab, and I'm already logged in, so this isn't really going to work. But if you go to solidworks.com, right? /xdesign. Watch this. It goes directly to, well, one of the If We 3DEXPERIENCE platform tenants. Now, I'm already logged in, so it takes me right to it. But had I not been logged in, it would take me to a login screen, and putting in my credentials will take me to my tenant. Something I didn't know. I thought it was the simplest thing, but man, was that convenient, because all I needed was a computer with an internet connection. Nothing else, and I had my models. So that was fantastic. Now that I'm on the platform, I'm going to switch over to my Cloud Design tab, which for me is nothing more than just already having my xShape or my xApp set up and my bookmarks editor off to the side. Now here's the magic. The free form of this product is really more about your imagination than anything, and you can really just kind of keep working at it as you go. But like I said, there's some foundational functions here. So we're going to start by beginning a brand new component and just give you some ideas of how this works from scratch. Here I can give it a name if I like. I can go ahead and assign a bookmark if I choose. That's a nice new function here of our latest functional development. At that point, we're going to go ahead and just simply start a brand new document. Okay. This is the essence of Subdivision, is we start down here at the bottom on our Subdivision tab. Now, there's a few primitives that we would begin with here. And really what I'm doing on this is I'm trying to start with roughly the shape that I'm looking for. Now, to remind you a little bit here on the camera, I'm going for this nice little shape here that looks like a dolphin. And this will start to take shape fairly quickly, no pun intended. I'm going to begin with a box. Now, when I'm using a box tool here, I like to look at this in more of a plan view and just simply take the box as is and throw it in place with a little click. Now, by doing that, the first thing that you're going to see there is that this box is kind of just sitting there in space. Now, first of all, the box itself can be scaled really uniformly if we want to, or we can go ahead and start grabbing on any of the push-pull handles on screen. Now, there's also the capability of adding additional things like loops, and really at this point, you might be tempted to add more detail, kind of thinking you know where you're going, but the more detail you have right now, the more you have to deal with that detail. So let's start with a less is more attitude. I've heard that said several times, and I'm going to keep saying it every single time that I use this. And at this point, we're just going to go ahead and stay with the box as is. Now, it's a little bit of just kind of homework here. I didn't really throw that right in the middle. So I want to show you how the robot first works when it comes to moving and manipulating this tool, this feature. I'm going to roughly place that in the center. And when I say roughly, well, I've got some tricks here, so I'm not going to worry about that so much. But I'm also going to go ahead and click over here on my compass and turn to the side and simply move this around a little bit. Now, the robot is the manipulation tool, and whatever is selected on screen is what's going to be manipulated by that. So looking at the side view here, if I start to move using this little planer tool, you'll see that the robot moves everything. Well, of course, grabbing the axes is going to move everything selected, specific to those particular axes. What's really interesting about it is that when you start to grab these other little dots and handles that we have, now this handle right here allows us to go ahead and scale things, but this is also based on where that robot happens to be sitting. Now, another part about this as I'm moving forward is if I'm using the Alt key, it actually will scale in all directions when you grab those handles. So the Alt key is really a nice little accelerator for those things. Now, like I mentioned, as we use these handles, it's all based on where the robot happens to be. So if I click the robot, you'll see that it actually goes transparent, even tells us down here that the robot is currently detached. And I can use the handle now to move the robot itself, not what the robot has selected. Now, by clicking and reactivating it and putting it into position, the robot is now on the left edge, which means as I scale things, again, it's going to be relative to where that robot sits. So really interesting thing as to the way that works. Now I'm going to click in the background and deselect. And we're going to use a little bit of just more of an isolated or random selection here. Now with a basic window here, I'm going to select all of the nodes on all of the faces at the end of my body here. And as I go ahead and start to manipulate things, you'll see once again that only the things that are selected on screen are what happen to be actually moving. And right now we're selecting through the part, so everything I'm selecting on the front is actually selecting right through to the back. The point I wanted to show here, though, is that when we're selecting specific items, everything adjacent to that more or less has to update relative to the positional changes, but has to also keep the C2 tangency at this point until otherwise stated. Now that enables us to go ahead and move things around, maybe throw a little twist on things, like we might be working with that tail here pretty soon. Not quite sure where I'm going with that just yet. But if I go ahead and take a look at this from the top, for example, let's go ahead and just hit our manipulator there, and I'm going to go ahead and maybe narrow that tail down there a little bit too. So you can kind of start to see this little dolphin taking shape just with those few pushes and pulls on our robot. Now I'm going to focus next, and I'll click over to my PowerPoint for a moment so you can kind of see where I'm going here, is I'm going to focus next on this little snout area. Now in order to do that, what I want to do is go ahead and add a little bit of geometry here. This is a really fun function. What I'm going to do is select just one face at this point, and I want to add geometry there. So I'm going to go ahead and use down on my toolbars here at the bottom a nice subdivision function called extrude. It's basically like throwing a ball of clay at whatever I have selected on the screen. By hitting extrude, what it's going to do is give us a nice preview. Now there's a difference between the tools I use on the toolbar and some of these accelerator tools you see popping up next to my quick tools. We'll talk about that in a second. The point of this is I get a good preview as to what I'm looking at, and if I accept that, you'll see that it simply goes ahead and adds geometry to the front of this part. Now with that, I'm going to select something different. In this case, I'm going to select a face. Now instead of picking points, now I'm going to manipulate this face, and by doing so, everything around that face is going to have to update and again maintain that adjacent tangency that we have there. If we use our Alt key, we'll be able to scale that outward if necessary. And maybe if I go ahead and select this edge up here, we're going to go ahead and move that edge upward. And again, you can see how everything is adjusting as a result of that. We take this face out here, maybe twist it and move it down. That looks pretty good, right? Now I want to take 1 second here and first of all take a drink. But to state that when I show this product here, I've actually had more of a market shift in how I demonstrate this product. When I'm using this freeform tool, I literally want to work more freeform. So I don't spend as much time rehearsing these as I might have done back in the mechanical design process. And that's really because mechanical design is a process, and you can boil it down to a series of features and functions in an order. But when it comes to organic shape creation like this, it's about knowing how these tools function and approaching it in whatever order the ideas pop into your head. And that's really the beauty of what we're dealing with right now. As I'm looking at this, I'm thinking about things like, you know what, this is just a little bit, too wide still, so I might just go ahead and grab that and narrow it down. But there's just these little things that I keep doing as I work with it that just kind of make some changes to it. Now, as I want to, I add detail here. And we didn't add a lot of detail to the middle, but I need a little bit more detail in this area. And what I'm going to do is just pick one of these edges and use my quick toolbars to insert something called a loop. Now, a loop are those loops that you see on the part already. But this enables me to go ahead and add additional detail if and when I need it. Now we again say less is more. Well, in this case, maybe I add a couple and I decide, okay, that's great. Or if I don't want it, I can always pick the loop and hit delete on the keyboard, and it will actually delete that entire loop and reorient the adjacent stuff. So it's really a great way to go ahead and get more detail when necessary. And on this one, maybe I want to go ahead and just deal a little bit more with this curvature. So I'm going to grab these faces and move those down. And if I grab just this loop in the middle, well, that's going to enable me again to go ahead and grab those edges and twist them and really deal with a little bit more of the shape that I want to add to these. Okay, this part is most definitely symmetric, and that happens a lot with organic geometry like this. And when symmetry is involved, of course, we want to come down here to our sub-D features, and we want to use symmetry to our advantage. Now, by turning symmetry on, what it will ask me to do is select a plane. And I roughly had this in the center. I wasn't so worried about it, because once I do select symmetry, what that will do is use that plane as the literal center of this part. Now, while that is active, you're going to see that green edge right down the middle. And that really enables me to do half the work. In other words, I can pick one face, and you'll see that that one face is going to go ahead and really work with what's on both sides of this part. If I go ahead and pick this face up here, again, you're going to be able to see that as I move the geometry on one side, both sides are going to adjust as a result of that. Now, even so, if I want to go ahead and maybe come out here and add these tail pieces in the back, let's maybe go ahead and grab 3 faces here. And quickly we'll use our quick toolbar to add the extrude this way. Now this is going to be no preview and symmetry is on. So watch what happens here. It's going to add it on one side and then bam, it's going to add it on the other. And everything that I do on one side when it comes to selecting faces, using my robot to reposition or to twist or again to reposition those or even scale those, it's all going to happen on both sides of this part as we work that. So again, this is something I don't like to rehearse because I kind of like the process of what my brain puts me through when it comes to adding these additional geometries here. Now, in addition to that, I got these little side fins. We're just going to fast track a little bit more because there's other things I like to show you, and we're already 20 minutes into this, but I'm having kind of a good time here, so I hope you guys are too. I want to add one more loop here because I'd like to control this a little bit more specifically up in this area, and by adding one more loop, that kind of gives me a space that I can grab just one of these side pieces here and maybe go ahead and add a little bit of geometry there just by hitting extrude. Again, we have our symmetry on, so that's going to work on both sides. Now, if I hit that face again and hit extrude again, it's just going to keep stacking it up, and it's going to keep those loops in there. And again, with whatever's selected, that determines what's around it and what also is going to happen as a result of the adjustments and the shapes and the changes that we get here. Really, what I recommend is just playing with it. Right now, I'm kind of liking that, but maybe not. Control Z is always your friend. Hit an undo, and it goes back to where it was before. But don't be afraid of this process. It is incredibly enjoyable. And really, when you see things that look kind of weird like that, well, just kind of look around and maybe see how you can manipulate those. And this will give me an opportunity to show you a little bit more about the robot, because as we look at it, it's sitting on screen in a particular orientation. Now, sometimes it's sitting on the screen, sitting in this particular XYZ orientation. But like I said before, when you click the robot, you have control over it. Now, right-clicking on it now allows me to have it orient itself based on the selected geometry, which is going to be variable based on the normal to whatever I've picked, or it's going to go ahead and be a specific orientation on the screen like XYZ. I like to keep it specific XYZ because what that's going to do for me is really go ahead and allow me to keep it very right-hand rule relative to what I see up in the corner, and it gives me a very good, controllable or more logical orientation when it comes to the way that we use this robot. All right, last thing up here on top. We need our dorsal fin. Now, the dorsal fin is going to go right down the middle of the part. So symmetry, well, I guess we could work with that or without that. For now, let me just turn symmetry off. We don't necessarily need that. Now, the symmetry being off doesn't necessarily mean that this part doesn't stay symmetric. It just means that things aren't necessarily active as we're doing that. What I do need, though, here is another little region here to work with. And I'm going to do that by selecting a couple of faces and using an area called Subdivide. What this will do is give us 5 faces, one in the middle, and then adjacent faces so that we can control essentially how the adjacent transition or tangency is going to work. Now, because I have a symmetry axis there, we actually got more than the 5 faces because, again, we're bisected here, so these faces in the middle are more multiples. But really, the reality of this is all I have to do is just select these faces in the middle, and by using my robot to pull those up, I'm going to have all of the faces around it maintain those tangencies as necessary, while I go ahead and just simply manipulate the way this fin looks. That looks absolutely fantastic. So again, very, very easy to go ahead and put these kind of things in place and just grab what's on screen and go ahead and move those around as necessary. But really, really just want to go ahead and enjoy that. Okay, I'm going to do a real quick check here just to see if there's any questions up in the chat. And while we're doing that, I just want to go ahead and get switched over to another model here. So let me just go over to my PowerPoint here. We're going to go ahead and get switched off of that. Okay, we're going to come back around to those. While I've got you for a second, I did mention that I do have a video series. I made about an hour-and-a-half video where I really just went, again, unrehearsed through the creation of this. And the discoveries along the way were kind of enlightening. And it's really one of those things that I enjoy about the process of learning these tools. The developers have created some fantastic software. It's really fun to discover what they have created. Now, if you hold your phone up to the QR code, that's going to take you right to our YouTube channel and to episode 1 of 3 of my creation of my childhood favorite here, once again, Odie and Garfield. Now, what I also had, and was alluding to a little bit before this, was here on xShape. Here's the creation of the file that I just made. But like I said, creating something that's a bit more exotic can come right down to, just really what your imagination will limit you to. So that's one of those things that I absolutely love about this. And, like I said, you can go crazy with it and create any organic shape that you're looking for. What I want to go ahead and focus over or shift over to next as this file is coming up is I want to go ahead and get into kind of one of the more, for me, realistic development stories, which has to do with how SolidWorks and xShape will play with each other when it comes to sharing data. And for me, that's a story about Sculptor and SolidWorks and how I always start a project. Now, I have another video series up there that I'll allude to here in a second that's going to be developing throughout the year, But essentially what we want to do is show you how to use each tool for, again, what their advantages are. And, SOLIDWORKS is hands down the best mechanical design software in the world. So we want you to stick there with what you've already got. For your entrepreneurs that are out there, people who maybe don't have SOLIDWORKS data, well, xDesign's the ticket for you, and that's going to be completely in the cloud like we have xShape here. But for those who are kind of in a transitional period or are getting access to a new toy like xShape like I am, we want to show you a little bit about how they talk to each other. Now it has a little bit to deal with the platform in general and the way the data sharing takes place between those. But what you have in this situation is both SOLIDWORKS and xShape and xDesign data living together in the PDM platform with revision control and check-in and check-out and just maturity states that are securing your data at every step of the process. But you can access that data from any computer with an internet connection, including using SOLIDWORKS. So I want to show you how to use some of the SOLIDWORKS data in the xShapes or xApps, and if we have some time here, maybe the opposite of that as well. But for starters, a project I'm working on is integrating some things that I've purchased into my boat. And the final one here, just to show you where we're going to this is something I've purchased, and I just simply love to model these up so that when I design things in my other applications, it's really more of a matter of executing the form, fit, and function, not having really anything left to chance. So I will take the time to use my SOLIDWORKS modeler to go ahead and build these mechanical components and then simply use them over in xShape. So that's the purpose of what we're about to do right now. Now what it does is it manages what we refer to as the CAD master, is it shows us exactly who happens to be seeing this, what the originating product was for design, and it's going to go ahead and control where those edits can be made if and when edits happen. But like SOLIDWORKS parts and assemblies and drawings and the associativity that they have, we also have a great element of associativity between any of the 3D XML data on the platform and native SOLIDWORKS data. It's really a beautiful thing to watch it happen. Now, what we're going to be dealing with is some more advanced concepts. I want to show you a couple of additional things like the cage view on the 3D body that we have here and some of the other alignment tools that are also available with this. Now, I'm going to show you this video that's coming up here as well, but until we get to that, let me just go ahead and move back over into my xApps, and we're going to start this process once again with kind of a new file and a new approach. Now, as I mentioned, these files were created originally in SOLIDWORKS. Now, sitting in my SOLIDWORKS seat, if I'm looking at my data management tools over on the side and I simply do a search, I'm able to find any data that I have on my 3DEXPERIENCE platform. To utilize that, it's a simple drag and drop directly into SOLIDWORKS. Now, when that data opens up, what you're going to notice is that it is native SOLIDWORKS data. And that data plays on the platform, just like the 3D XML and xShape data that lives up on the platform. But the reality of that data is that when we want to go ahead and utilize it, we're going to just use drag and drop techniques in order to integrate these data points together. Well, let me get through that. Sorry, I got my little PowerPoint popping out here on me. Now, we're going to go ahead and hop up one more time, like I said, up into my xApps here. And I want to go ahead and set this up properly. Okay, so we're going to start a new component. And the purpose of this new component is to go ahead and build, like I said, another organic shape that happens to be out there. Now, I'm going to pop back over to my SOLIDWORKS for a second and just see if that search has finished up. I think we're still working on another little piece over on that side. So I'm going to go ahead and actually utilize what I'm working on this side. The beauty of 3DEXPERIENCE platform data is it can be drag and dropped from anywhere. It can be right from the SOLIDWORKS session in the SOLIDWORKS search, or if I happen to just be using my 6W tags right here in my search application. What's really great about this, once again, is that as we are going to head to locate our data, we just have to know little bits about it. And this is slightly different than a lot of the approach that we have from Windows data management, if you will. Finding your data in Windows is about knowing the marching order and the depths of your folder structure, and it's one way to, and the only way you can, organize your data. However, when we're talking about the platform, we have the ability to search for any little bit. And when we find that data, we can find multiple versions of that data that happen to be available for us. And whichever piece of that data we want to use is just a simple drag and drop away in order to go ahead and utilize in our applications. So it's really kind of an interesting process as to how these types of things actually function. So with that data here, I'm having a little trouble getting that data popping up here, guys. Sorry about that. You can rehearse all you want, but you're never going to have everything popping up every time you want it to. Let me go ahead and just get out of this 1 second. While we're waiting for that thing to drop out here, so I can go ahead and grab some of my 3 gang data there. What I want to do with this particular panel here is I want to go ahead and just show you again some of the organic approaches that I might use for something like this. Now, when I'm using things like the box tool, sometimes I want just full organic shapes, and other times, really, that's not what we're looking for. Other times, we want to control these edges in a much more in-depth way. So I'm going to put this in a position where I might create, like I said, this electrical panel that we have on the outside of my, the housing on the outside of my panel. Now, for a shape like this, I might start out with, once again, the less is more operation. But the purpose of this is I want to go ahead and actually have a little bit of a fascia here that's going to be used in order to house or to mount this panel into. Now, that being said, what we're dealing with here is something that's not going to be rounded like we see here. So I want to get a little bit into the tool that I had called crease. Now, a crease is an important thing because it allows us to really emphasize or de-emphasize edges amongst our part. I want to put a crease on this front face, but I'm first going to start with a subdivide. Now, instinct for me would have me window selecting, and I want to show you a couple of the behaviors that actually happen. First of all, with this window select, you see it's selected vertices. So we'll show you a little bit of this, and then we'll wrap this one up. But we'll show you the vertices there, and you'll see that it actually selected through the part as well. Now, there's 2 things that I can use for technique here, since we're in an instructional situation. First, we have a filter up here that enables us to choose the types of things that we can select. Now, there's some new behavior here in this new functional development I'll actually talk about here quickly as well. But I want to select just faces. So let's do that, and we'll window select left to right. Okay, that's better. It got faces, but again, we're still selecting through the part, so not quite what we're looking for. This button, however, hugely important. Select only visible elements. All right, I'm going to go ahead and select that, and then we're going to window select. Uh-oh. We're back to selecting vertices. However, we only have the ones on this side. Now, why'd that happen? Well, here's a small cosmetic change that happened in the last functional development. I actually have a thumbtack that shows here. So when I want it to be sticky on just this entity and not any entity, I can hit that thumbtack there, and now every pick I'm going to have from that point on is going to be faces. Neat little trick, but brand new to this functional development, constantly evolving. All right, with this face selected, let's go ahead and do a subdivide. And what that'll do is, again, give me a loop around that edge that's going to allow me to remain adjacent on these sides while manipulating these internal faces. I'm actually going to do that one more time. Let's go ahead and window select. One more time. Let's go ahead and add one more loop to this. Okay, so I want to show you how these outside loops happen because a crease is an important thing. First, if I was just to go ahead and select these faces and use my robot to go ahead and actually just pick and drag on the screen, what we're going to have here is a movement where it's going to maintain those tangencies. See how that looks? It's not quite what I'm looking for. So if I go ahead and select that, what I really want to do is control or emphasize how these edges work. So here's where I want to be able to pick anything. Let's go back to any edges. First, if I double click a loop, it selects the whole loop. That's very cool. Now it does that if it's tangent. Here I'm just going to turn this into what we call a crease. Now nothing's going to happen right now, but that's okay. I'm also going to double click this edge. It didn't select all the way around, but it looks like there's not quite a tangency in this corner, so I guess I understand. But if I use this shift when I pick on what is now going to be the south side of the midpoint, watch what happens. I'm going to hold shift, pick this edge, and it loops and picks the continuous or partial loop select, as we call it in SolidWorks, all the way around. So once again, pick one edge. I'm going to pick shift on the south side of midpoint, so that indicates the direction. And when I pick that edge, that's the direction it goes. Pretty sweet. Let's make a crease there as well. Okay, now I've had a graphical issue here, so I'm not going to run away with this, but I want to show you what I'm talking about here. These edges are supposed to change color. Let me just get out of this feature for a second and double click and get right back into him, because I want you to see that color. And the color right now is purple. Not sure what that is, but we'll get that taken care of. In any event, that shows me the crease. Well, watch what happens with that. All right, now let's go back to face selects and let's grab these faces. As I pull these faces out, what you're going to see is what those creases now afford us. And look at that. It's got a nice sharp edge, whether I'm going to inset that to put my electrical panel on it or whether I'm going to protrude that. Now, what's also beautiful about this is the initial crease is absolutely sharp. But if I come in here and select that entire set of creased edges, oh, let's use our shift select, right? Grab them all. I want to actually grab crease off of the toolbars, because what crease does down there is it gives me some input. Now, this will show you exactly what I mean when it talks about whether a crease can be emphasized or de-emphasized, and it can also be sharp, or it can still be Class A or C2 tangency. This button right here will make it a smooth crease. Now, without that button pressed, as I make that crease sharper and sharper, you see how that turns into an absolutely rigid crease, just like folding paper. However, if I simply bump it and say smooth, what it will be is as sharp as it can be, but still a Class A tangency there. And as I de-emphasize that, it will simply smooth it out as necessary. So it can be a sharp crease or it can be a round crease. I'm going to leave this one sharp. I'm going to leave this one smooth. Actually, let's check that. I'm going to go the opposite. We're going to go sharp as can be on this outside crease. That looks good. And then I want to go ahead and say smooth on this inside crease. How about we say that? And once we smooth that inside crease, what we'll now have is a pretty great looking part. Then if I wanted to go ahead and throw an electrical panel right here on the front, as I pin my face selections in place, this is going to give me the type of geometry that would definitely be nice for housing this material. That looks pretty good. All right, that looks pretty nice. Now, the last couple of things that I'm going to do with this, and what I would actually do had I made my electrical or housing panel on this, is I'm going to go ahead and just add a stand or a mount to the bottom of it. Now, by doing this, once again, I like to go ahead and grab multiple faces and use the extrude tool, because that really is adding material to this. It just protrudes out, and if you continue to do that, it's going to add additional material to that. Remember, you have full control over everything. So window selecting is either going to get us what we have selected up here with our pin, or what we have selected up here with just what we see. And I'm going to turn both of those off because frankly I want to pick everything straight through the part and really be able to go ahead and start changing the shape of the foot that we have down here at the bottom. This gives me something to maybe stand on. Now for the last piece of this, I want to flatten this bottom. Now I might be tempted in some cases to go ahead and take those faces and make a subdivide. We'll take a look at that. Oh, that actually worked out really good. I'm going to stick with that. Again, doing this live, you're not really sure sometimes what kind of cool things you might come up with. But what I also want to do with this is I want to make sure that it is nearly a virtually flat base to this. So with that, I'm going to simply double click and grab this entire loop around the outside, and we're going to crease that bad boy again. Now by creasing that thing and making it a sharp or non-sharp crease, we're going to get a couple of different controls here, but I'm going to go to a fully sharp crease at this point. Now that being said, I've got some faces here which can kind of move around and do some things. But again, I want to show you a couple of things about how all this can work. And one is the ability to go ahead and select a bunch of things and make them flat or aligned to a planar face. Now I've pulled these out or kind of domed them on purpose here just to give you a little effect there. But if I control select all those faces, we have a great series of alignment tools. And this will be the last thing I leave you with today. The alignment tools enable us to grab a series of pretty much anything. They could be faces or points or edges. Again, the control is up to you. But you can align that to some existing geometry, to imported geometry from SOLIDWORKS, had I pulled that stuff in, or in this case, really to any geometry like a plane. Now in my case, if I align that to this top plane, you'll see that flat face will go perfectly smooth and everything selected will be absolutely linear there. Now at this point, if I like that linear, but then I wanted to go ahead and take this outside edge and maybe go ahead and deal with just a little bit of a smooth crease on that, we can do that. And that's going to look really, really nice. But it's going to ensure that we bridge not only this organic shape, but also a nice flat analytic surface for the sake of mounting up to something else that might be, another physical part. But the reality of all of this is that it's a tool that enables us to really kind of have endless development in what we might want to do when it comes to shapes. What you have selected is all up to you, and everything moves in a way that you can go ahead and do some very, very nice what-ifs in order to create those. Now, I like to do what-ifs by actually exiting these bodies, going over here to the tree, and grabbing the sub-D body and actually hitting a Control-C, Control-V. That's a basic copy-paste. That gives me the ability to just go ahead and start with what I have here on the screen, and then with that, that's going to go ahead and actually allow me to then make a second subdivisional body that maybe I'm going to go ahead and try some other types of what-ifs with. And really, for me, it's just about grabbing all the points and dragging them to a different spot. And now I'm off and running, trying some completely different things, as the case may be. So the development that we can do within this tool and the capabilities that it affords us are really very liberating when it comes to the shapes that we create without the traditional and excessive sketches and guide curves and all those types of things that we need to use to create those. So the beginning of this project, and really kind of the bridging between the SOLIDWORKS data and how I went ahead and merged those two together, is in a 6-minute video that I have out there that's really, again, the beginning of a series I'm going to produce throughout this year. But I'm really relying on these tools quite a bit because I love to create not only on the screen, but also using our extensive additive manufacturing capabilities with GoEngineer, as I like to hold that part in my hand and have a final usable part as my end result. And that's where I prefer to take these kinds of things. So with that, I'm going to look at the questions just a little bit here and see if we have some time to answer each of those. While I have that up there, feel free to go ahead and jot down these links or take a screenshot, and make sure you follow us out there. Again, we're putting up content all the time, and everybody has the ability to go ahead and really, show something that maybe somebody else maybe didn't think of, or an approach that was unique, or again, a utilization of these tools that have a purpose to them, but maybe have more capabilities just by the way they're applied. And that's really one of the superpowers of application engineers like myself happen to be. So if you have an idea, reach out to us also, or any other questions. We have our support. Go ahead and hit us at support@goengineer.com as well. All right, let me take a look here and check some of the questions. Again, I want to thank everybody. I know we went over a little bit on time on this one. I think I went ahead and closed out my PowerPoint and everything there. Yep, everybody saw those. So that's fantastic. But I want to thank again everybody for their time today. Believe me, I do not take it lightly when a bunch of individuals share what to me is probably the most valuable thing in the world, which is your time with me. So I hope that you found something beneficial into this. Honestly, that solidworks.com/xdesign probably would have been the only thing you needed to see today if you were a platform user who has struggled to just simply log in when you're not at your own computer. That thing is awesome. But aside from that, reach out to us. We want to show you what we know, and we want to learn from you and your process. So if there's anything that you're wondering whether xShape might be useful for, or you just want a little bit more demystification, please reach out to us. We have a platform team that is all over these applications and is ready to kind of, again, help you through the waters that we have also navigated ourselves. So once again, thank you very much. I appreciate your time today, and hope you come back again. Check us out on YouTube. Hit the notification and subscribe buttons there, and when these videos go up, you'll be notified, and you'll be able to go ahead and forward that out to your colleagues as well. So thank you very much. Appreciate everybody. Thank you for your time today.